Hello everybody. In this video, we are going to discuss the angle bisector theorem, which is a very important result used in many times in Olympiads. And it is, it can be proved on the basis of the basic proportionality theorem, which you also call Thales theorem. So let's see the angle bisector theorem, some questions on it, and then we'll prove it as well. Let's start with the thing. So basically, what is the angle bisector theorem? It says that if you have got a triangle like this, suppose it is PQR, right? And then you take bisector of one angle. It means this angle is equal to this angle. Suppose this is S, right? You have got a triangle PQR and PS is the bisector of angle P. Then as per the angle bisector theorem, the ratio of sides including the angle bisector, that is PQ upon PR, the ratio of the sides including the angle bisector is equal to the ratio in which opposite side is divided by the angle bisector. It means QS upon SR. Again, I will say, the ratio of sides including the angle bisector PQ upon PR is equal to the ratio in which the opposite side is divided by the angle bisector. So this is the direct statement on the basis of the angle bisector theorem. And this is the internal angle bisector theorem basically. This is for internal angle bisector because this is the bisector of internal angle P. There is an external angle bisector theorem as well. We'll do that as well. So first, let's do a direct question on the basis of this internal angle bisector theorem. Let's make the figure as per the question. ABC is a triangle in which AD bisects angle A. So let's make this. AD bisects angle A. Suppose like this I can do, right? AD bisects angle A. It means this angle is equal to this angle, right? And it is also given that AC is equal to BC. This is equal to this. AC is equal to BC is given. So I hope you understand that. AC is equal to BC. Fine. And angle B is given 72 degrees. This is 72. I hope that is clear. And CD is equal to 1 over here. Correct. Then we have to find the length of BD. Suppose BD is X over here. That we have to find. So before actually using the angle bisector theorem, let's talk about some angles in this triangle. Then only we can proceed further. So you see over here, it is given that AC is equal to BC. AC and BC, they are equal. So if this is 72, this will also be 72. This total will be 72 only. Because angles opposite to equal sides of a triangle are equal. And then you see this is the bisector. It means this is 36 and this is also 36. I hope that is clear. Correct. Now let's see over here. What will be this angle, guys? If I see this triangle ADB, what is this angle? This will be 180 minus 36 plus 72. Correct? And what is that? This is 180 minus that is also, you can see, 72 degrees. 180 minus 108 will be what? 72 only. So what does it mean? This is 72. This is 72. Correct? Now you see, if this is 72 over here, this angle will be what? This will be 108 degrees. Why? Because these are forming a linear pair. The sum of these angles must be 180 degrees. Correct? Now if you see this triangle over here, what is angle C? Angle C, if you want to find, that is equal to 180 minus 36 plus 108. 108 plus 36. So what is that equal to? 180 minus, this is 144, and you can just check it. What is that? 36 degrees, I guess. So this is also 36 degrees. So are you able to observe over here that if this angle is equal to this angle, and this is the if this angle is equal to this angle, if this is 1, this is also going to be 1, because sides opposite to equal angles of a triangle are equal. And then you see, if this is 72 and this is 72, this is also going to be 1, because sides opposite to equal angles of a triangle are equal. Now we can use the angle bisector theorem over here. And one more thing, if this is 72, this is also 72, because it was given AC and BC, they are equal. So you see, this total is what? X plus 1 over here. This is X and this is 1. So this total will also be equal to X plus 1. I hope that is clear. So now we have set the field so as to use the internal angle bisector theorem. You see, this is the bisector over here. So can't I say X plus 1 upon 1 is equal to 1 upon X? Or you can write over here that AC upon AB, the ratio of sides including the angle bisector, is equal to the ratio in which opposite side is divided by the angle bisector. So that is CD by DB. CD by DB over here. So AC over here is X plus 1. AB over here is 1 itself, and that is equal to CD is 1 and BD is X over here. So 1 upon X. So we have to find the value of X. Just simplify that. That is X square plus X minus 1 is equal to 0. So you have to solve this quadratic equation. X will be what, guys? You can use the quadratic formula. Minus B plus minus square root of D upon 2A, where D is the discriminant, right? So you see, A is 1, B is also 1. So it is minus 1 plus minus square root of discriminant over here is what? B square minus 4AC. So that is 1 square minus 4, A is 1 and C is also minus 1. So that is equal to, if you simplify this, this is basically 5. Correct? So this is going to be 5 upon 2A over here. That is 2 into 1. So two values you'll get from here, guys. One value is root 5 minus 1 by 2. And another value is minus root 5 minus 1 by 2. Now you see, X is a length. It can't be negative. You'll neglect this. So root 5 minus 1 by 2 centimeter is the answer. This is the length of BD over here as per the question. I hope this is clear, guys. So it's an application of the internal angle bisector theorem over here. If you don't know the internal angle bisector theorem, then it might become hell of tough, to be very fair and honest. Okay. So let's proceed with the external angle bisector theorem. This was internal angle bisector theorem. You have got external angle bisector theorem as well. So for example, you've got a triangle like this. Suppose it is PQR. Suppose you are extending this side. Fine. This is the external angle P. You take the bisector of external angle P over here. Means this angle is equal to this angle. And suppose this is PS. Right? What I am saying, PS is the bisector of external angle P over here. So how will you write the external, what is the relation which you will write? So you see, I am telling you very patiently that how to remember it. How will you remember what will be the relation? See, make the same triangle PQR. Make the same triangle PQR. Take the external bisector inside the triangle. Okay? Take the external bisector inside the triangle like this. Now what will be the relation using the internal angle bisector theorem? That will be PQ upon PR. PQ upon PR is equal to QS upon SR. Is equal to QS upon SR. I hope that is clear. So you see, the same relation will be applicable in this triangle as well. What I am saying, I'll repeat once again. Take the same triangle PQR, take the external bisector inside the triangle, and then write the relation as per the internal angle bisector theorem, because that's easy to remember. That is PQ by PR is equal to QS by SR. The same relation will be applicable over here as well. PQ upon PR is equal to QS upon SR. That's it. You don't have to bother about it. So let's do a question like that. In triangle ABC, AE is the external bisector of angle A meeting BC produced at E. So over here, AE is the external bisector of angle A. Make a triangle like this in rough. So that is ABC. External angle A is this. You take the bisector of it, meeting BC produced at E. This is the situation, right? Now you see over here, AB is given 10, AC is what, 6, BC is 12, and they are telling you to find CE, suppose it is X. Now how will you write the relation over here? Many students will do this, AB upon AE, BC upon CE. That is not correct. How will you do that? See this, make the same triangle ABC, take the bisector inside the triangle, right? Now what will be the relation? Using internal angle bisector theorem, AB by AC is equal to BE by EC, That's the statement as per the internal angle bisector theorem, right? Now just the exact result will be applicable over here as well. AB is what over here, guys? AB is 10. What is AC over here? AC is 6. What is BE over here? BE is X plus 12. And what is EC over here? That is X only. That's the relation, guys. 2 5s are 10, 2 3s are 6. You can obviously calculate it. 5x minus 3x, 2x. So X is equal to 18 will be the answer. I hope you understand that, right? So let's prove the internal angle bisector theorem over here. You can say it's an application of the basic proportionality theorem, nothing else. See this, guys. So if you have been given with a triangle over here like this, right? Suppose it is ABC, right? And you have got this bisector ABCD. Fine. It means if this angle is X, this is also X. What we have to prove? AB by AC. We have to prove AB by AC is equal to BD by DC. This we have to prove. Now how will we prove it? There is a construction for it. The construction says that you have to draw a line parallel like this and then join this. This is suppose ABCDE. We have constructed this parallel to this. It means AD parallel to EC we have constructed. See this. Now the proof is pretty simple. See this, guys. If AD is parallel to CE, can't we say this angle is equal to this angle? Corresponding angles. Correct? Can't we say if this is X, this will also be X? Alternate interior angles. So if you see the triangle ACE, in that triangle ACE, if we have proved these angles to be equal, can we say AC is equal to AE? Yes, we can say that. Now you see over here, AD is parallel to EC. So can't we say AB by AE is equal to BD by DC? Basic proportionality theorem, or you call it Thales theorem, BPT in short. Correct? The only thing which you have to do over here is, in place of AE, can we plug in AC over here? So AB by AC is equal to BD by DC. And you see that proves the angle bisector theorem, internal angle bisector theorem. Have we proved AB by AC is equal to BD by DC? That's it. That is the proof of it. That's a direct proof, right? Now you see over here, we can also prove the external angle bisector theorem as well. So for example, you have got a triangle like this. Suppose it is PQR. And then you can extend this side and you take the bisector of external angle P. Suppose PQRS. It means if this is X, this is also X. Correct? What we have to prove? You compare it, you make the same triangle in rough, right? And you take the bisector inside the triangle. You have to prove PQ by PR. PQ by PR is equal to QS by SR. Is equal to QS by SR. This you have to prove in this figure. Correct? Now same type of construction over here as well is applicable. See, over here we have made the line parallel outside the triangle. Over here we will make parallel inside the triangle like this. Suppose this is PQRST. So what is the construction? TR parallel to PS. Right? Now you see over here, if this is parallel to this, what does it mean? If this is angle X, this is also angle X, corresponding angles. Similarly, if TR is parallel to PS, this becomes a transversal. If this is X, this is also X. Alternate interior angles. So can't we say in triangle PTR, can we say over here that PT is equal to PR? I hope that's clear. Now you see over here, TR is parallel to PS is given to us, right? So can we say PQ upon PT? Just you see this, PQ upon PT, that is equal to QS upon RS. SR. Can we say that? QS upon SR. You have studied this corollary of the basic proportionality theorem, right? If this is parallel to this, you can say PQ upon PT is equal to QS upon SR. That is a corollary of the basic proportionality theorem. Now you see over here, we know that PT is equal to PR. So can I plug in over here PQ upon PR? That is equal to QS upon SR. Have we proved that, guys? PQ upon PR is equal to QS upon SR. And this is what? This is a corollary of BPT. Maybe the spelling is wrong, so I don't have to bother about that. I hope it is clear. So you see, that's how you can prove the external angle bisector theorem as well. So both the internal angle bisector theorem as well as the external angle bisector theorem, they are application of BPT. But if you don't know these things, it might create issues, especially when a question is a complex question in an Olympiad. I hope the concept explained is clear. Don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel. And don't forget to subscribe to the Telegram channel as well, because whatever is being discussed in these sessions, you can get the PDF in the live sessions after the class. Bye-bye guys. Take care everybody.